Welcome. This video is about how skills are becoming the new middleware in AI development, focusing on how AI agents actually get work done. LLMs excel at reasoning, planning, and summarizing, which live purely in language. However, they are useless at acting, unable to send emails, query databases, or call APIs that touch the real world. This gap, where an intelligent agent cannot execute its plan, is precisely what skills solve. Hard-coding tool calls doesn't scale due to several issues. It introduces brittleness, as workflows break when task requirements change. There's no generalization, meaning the model follows a fixed script without reasoning. It creates a maintenance ceiling, where complexity grows rapidly. Finally, it leads to a lack of reuse, resulting in capability reimplementation across pipelines. A skill is a callable unit of capability, a function or action an LLM can invoke to interact with systems. The model decides when to call them, and your code defines what they do. Skills range from atomic, single-purpose functions to stateful operations, and even orchestration for calling other agents. 4 principles for designing robust skills include narrowing the input surface to prevent hallucinations and returning structured outputs like typed dicts to avoid compounding errors. Also, use explicit failure signals so the model knows how to route correctly. Finally, write descriptions that teach the model about constraints and anti-patterns, not just what the skill does. It's important to know when to use RAG versus skills. RAG excels at retrieving knowledge, such as asking about a refund policy. Skills are for actions or fetching live state, like processing a refund or checking current inventory. They are complementary, not competing. Providers like Anthropic, OpenAI, Google, and Meta offer different skill capabilities. Anthropic supports parallel tool calling and extended thinking before calls. OpenAI provides JSON schema compliance and an ecosystem of integrations. Google enables native multimodal inputs and built-in code execution. Open-source models like Meta's Llama allow full on-prem deployment but require tighter validation. The development of self-evolving skills involves 3 levels. Level 1, skill refinement, improves existing skill descriptions. Level 2, skill synthesis, generates new skill code and validates it in a sandbox. Level 3 focuses on ecosystem management, creating a living library. Temporal knowledge graphs provide persistent skill memory to prevent agents from repeating synthesis mistakes. Workflow optimization is crucial for performance. Running independent skills in parallel drastically reduces latency compared to sequential execution. Utilize skill caching for both in-session and cross-session operations. Implement timeouts and circuit breakers to prevent cascading failures. Design skills with batch modes from the start, and use workflow integration tests to catch issues under production load. To optimize costs, route models based on skill complexity, using less expensive models for simple tasks. Reduce token overhead by using dynamic tool loading and compressing skill descriptions. Leverage prompt caching, which can deliver significant input token reduction. For high-volume invocations, consider open-weight self-hosting for a potentially 10x cost cut, but always do the infrastructure math first. Most importantly, treat agent workflows like financial transactions, assigning and enforcing a cost ceiling. OpenClaw aims to be the NPM moment for AI agents, using skills as instruction documents in Markdown instead of JSON schemas. It uses lazy context loading to only inject full-skill content on demand, reducing token usage. The ClawHub registry offers natural language discovery over thousands of skills. Note that skills can contain security risks like prompt injections, so always review third-party skill source code. There are still 8 major unsolved problems in skill engineering. These include skill selection reliability, degradation with more tools, and cross-model portability issues. We lack formal mechanisms for skill conflict resolution and standards for modeling side effects. Provenance, versioning, multi-agent negotiation, and standardized evaluation and benchmarking remain challenges. Skills are more than just implementation details. They are the primary interface between your AI system and the real world. Design them with narrow contracts, strong typing, and explicit failures for the model that reads them. Treat the skill boundary as a critical security perimeter. The models will figure out the reasoning. You handle the plumbing.